Okay, so today we're going to learn about comparing two proportions. So we're going to talk about two, whoops, let's try to pick maybe something like this. How about two prop, we'll just emphasize that, two prop z intervals. So we're finally graduating to a new type of interval, and we're going to start with intervals. I think intervals have a few extra conditions, but in this case, intervals are a little bit easier than tests to do in this setting. So, and we're talking about the difference. So you'll notice in the formula that we'll talk about the difference between two proportions that we take. They've got to meet conditions to be normal. First one should look familiar. So should the second one. Those are the same conditions we've used. Now this condition is a little bit new. We've had the independence assumption, but it is important to kind of think about, okay, we have two proportions we're taking, maybe men and women. Are they really independent or not of each other? Just kind of check that off if it's the case. Success and fail, at least 10 for both samples. Okay, so this is where we have to actually show our work for both samples. So you'll have to check that for both proportions, that they have at least 10 successes and fails. We've done that before. And there's one additional, there's another additional one, which is both sample sizes n must be at least 30. So kind of like we had for our mean sample means, this is a similar condition that we want our sample sizes to be at least 30. And this is only a condition for confidence intervals, which we're doing today. So we're doing confidence intervals today. Okay. So if the conditions are met, then we do P1 minus P2. Whatever P1 and P1, like proportion of men, proportion of women, something like that. And so we'll talk about that as our center. That's our point estimator in the middle of our interval, will be P1 minus P2. We'll just decide which one subtracts from each other. We could do men minus women, women minus men. It doesn't matter. Standard deviation, if these are the individual standard deviations of each proportion, similar to what we've done before, well, if I want to add these two up or even subtract them, it doesn't matter if I'm subtracting or adding, the same thing's true. When we add standard deviations, remember what we have to do? We have to take the standard deviations and convert them to, variance by squaring them. So we square each one, and then we add them and take the square root of the total. That's how we get our standard deviation. We've done this in the past where we've done that. So we take each standard deviation, square it. So we're going to take that one. So we're going to take this guy right here, and we're going to move it down here. Take this one here, move it down. And we're going to take the, we're going to square both of those. So square that one and square that one. And we're going to add them. That makes that a variance plus a variance. Take the square root of the total, convert it back to a standard deviation. And that is our formula for standard deviations. We might simplify it just a touch there. We might make it look kind of like this. Because there's no need to say, it's kind of redundant to say square root of something squared. Like if you think about it, square root of something squared, that really goes away, right? You're squaring a square root, so that really kind of goes away. So really, that's your formula. P1 Q1 over n plus P2 Q2 over n, all of that total square rooted. So that's how we come to that formula. And of course, if we're dealing with an interval, which we are here, dealing with intervals, so what's in the middle of our interval? Well, p hat, actually both p hats are in the middle of our interval. P hat, this is actually the middle of our interval, is p hat 1 minus p hat 2. Right, so that's kind of the point estimator plus our z critical value times the standard deviation. All of this is our standard deviation. And again, we're using p hat and q hat because it's an interval. If it was a test, we'd use p and q there. So here's a problem. Researchers did this in 2012. They asked a random sample of 799 teens about their social media and internet use. And then 2,253 adults, same questions. In these two studies, 80% of teens and 69% of adults use social networking sites. We want to construct and interpret a 95% confidence interval for the difference between the proportion of U.S. teens and adults. So they basically tell us very straightforward, we are finding the difference in the proportions. There are definitely two different samples. This is one of the n values. This might be, n of the teens, and then this one might be n of, the adults. And then they have two different proportions here. So we want to go through and start building our thing. So let's look at conditions first. Conditions would be random, of course, 10%, less than 10%, success fail, at least 10 for both. So we need to show the work for both of those guys. So that's important to show the work there. And then one last check, which would be at least 30 for both sample sizes. So both of those were, well, very large, 799 and 2253. So it passes all the conditions. All those are at least 10. It passes the conditions. If you're doing phantom, or panic, sorry, for a confidence interval, we're doing panic. Let's just think through panic. P is your parameter. In this case, you might want to define what P is. So like we could say in words, you want to write this down. P of T is a proportion of teens using social media. P of A is a proportion of adults using social media, something like that. So that's your P value. That's your P value. That's your P in panic. A, these are all the assumptions here for panic. These are the assumptions and conditions. N is name the test. In this case, it would be called a 2-prop. Z interval. Then I, panic. And so let's find the interval here. This is our formula for the interval. And so in this case, we're saying the proportion of teens from the sample minus the proportion of adults plus or minus the Z critical value times the standard deviation of both proportions there. So we're going to plug in our numbers, and we get 0.8 minus 0.69. So notice I did teens minus adults. I could have done it the other way around. That would have been perfectly acceptable. Z critical value is 95 percentile, so it's 1.96. Again, we're using P hat, Q hat, P hat, Q hat, but for this one's for teens and this one's for adults. So different N values there for each of them. We simplify that in our calculator, we get that. Multiply that in our calculator, we get our, this is our point estimator plus or minus our margin of error right there. And so we get our final results. This is, our lower bound of 7.6%, upper bound of 14.4%. And because this is, we did teens minus adults, we got two positive values here, which tells me that the proportion of teens is more than the proportion of adults, which we kind of knew from this. But it's interesting to me that both of those are above 0. So this is a significant result that we have. This is kind of our scripted response. This first part is very scripted. I'm 95% confident that the proportion of blah, 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 in this case teens, using social media is between 7.6 and 14.4% higher. We need to say if it's higher or lower because this is positive and I did teens minus adults. The teens is higher, so I'm going to say between that percentage higher than the proportion of adults using social media. I can go on to say, and this is really, as we get into the next chapter, we're going the next step, because the null, and let me explain why the null is 0. So the null is that nothing unusual is going on. There is nothing unusual here. We always say this point estimator is 0 when we're talking about a difference. In other words, there's no difference between men and women, or in this case, there's no difference between the social media use of teens and adults. We would just assume, well, it's just 0. There's no difference. There's nothing unusual going on here. But because 0 is not in our interval, 7.076 to 0.144, that's clearly both of those are bigger than 0 on the number line. If this is 0, 0.76 and 0.144 are above 0. So because our whole interval is above 0 and 0 is not in that interval, we would say these results tell us there's a statistical significant difference in social media use between teens and adults. And that's really not that surprising because probably knew that teens use social media more than adults. So go ahead and get your calculator out, and we're going to plug some of these numbers in and see what happens. So get your calculator out. Okay, so I'm going to hit Menu, Statistics, doing confidence intervals, and we are doing a 2-prop Z interval. And so you'll have to have a number of successes. Well, notice the number of successes here is actually 639.2. You never want to type in a decimal point when you're talking about number of successes on your calculator. So you've got to round that. And it's okay to round down in that case, 639. Did I type that right? Let me try that again, 639. Okay. And N1 is how many that's out of, so that's a total of N is 799. And number of successes, NP for adults, would be 1555. 1555. I rounded that number, and I believe the proportion there is 2253. So 2253, and it said 95% confidence, so I'll leave that 95% the default. So it gives us a lot of values here. Let me just kind of drag this down and see what this is. So you can see it's got a lower bound at 7.5%. We had 7.6%. Just a rounding error there. That's not a big deal. 14.3%, 14.4. Our p-hat difference, that's this. P probability of teens minus probability of adults was 0.11. They had it as 0.109, so 10.9%. The margin of error they had as 0.033, and we had ours at 0.034. That's pretty close. P-hat 1 was 0.799. I don't know if we ever wrote down what our p-hats were there, but if we had, it'd be right about that. And it gives you also the n values there for the two different. Again, you have to remember whatever you type in first. I typed in first teens, so that's my N1 in the calculator. So whatever you type in first, when you fill out that chart, is what is covered first there. Just want to mention this. So if you're doing this problem, well, let's wait on that one. This is the one I think that I'm passing out an example in class, and I worked this one out for you also. So if you want to try this from scratch, it'd be a good one to practice. But I also have a worksheet that I think you were handed out that goes over step by step how to do this particular problem. So hopefully that will help you. Enjoy. Try to do some confidence intervals now.